All right, in this video, I'm going to go over the remote day 5 solutions for AP Physics 1. And here we go. Hold on. All right, so this one, the period of a pendulum equation. Um, yeah, so let's go ahead and move this 2 pi over, and then we'll take care of the square root and stuff. Okay, so anyways, yeah, divide both sides by 2 pi. Okay, so TP divided by 2 pi equals square root of L over G. And I know you might be like, we already know what G is, but maybe if you're on a different planet, maybe you don't. Okay, so now we're going to square both sides. Okay, and then that's going to give us TP over 2 pi squared equals L over G. And then the suggestion here is to get the variable that you're solving for out of the denominator. So I'm going to multiply both sides by G. And then we will need to divide both sides by TP squared over 2 pi. And when we divide by that, it'll be the same as multiplying by the reciprocal. So that is going to give us this. G equals... Okay, the 2 pi will be on the top after we divide by TP over 2 pi. So 2 pi L over TP. That's squared, and that's squared, and that's squared. Most people would write 2 squared as 4, so I'm going to do that to not be a rebel. 4 pi squared L over TP squared. What an expression that is. Okay, so that one made me work for it. That's nice. Okay. Oh, look. It's just that easy. That is that thing that looks like a P. That's a Greek letter rho. Yeah, looks like a P. All right. Oh, wait. I should circle the answer. Look at that. There's the answer. Okay. Oh, dear goodness. Yeah, okay, let's move the A over. That's not that. Okay, that's not that bad. All right, cool. So x divided by A equals cosine of 2 pi if t, and we're solving for t. The way we undo cosines is we take the inverse cosine of both sides, and so that will be cosine minus 1 x over a equals 2 pi f t. And then we're going to divide both sides by 2 pi f. And that will give us t. So there you go. That is the expression of interest there. A little symbol there, it just means perpendicular, force perpendicular. This is pressure equals perpendicular force over area. That's the equation there. Solving for area, multiply both sides by A to get it out of the denominator. So then we can clearly see that we will need to divide both sides by P. So to isolate A, so A equals F perpendicular divided by P pressure. All right, that's lovely. Continuing on. Oh, how lovely. We're not doing crazy stuff on this one. Okay, so divide both sides by sine 2 pi ft. And yeah, cool. That's pretty much going to be it. So A equals x divided by sine 2 pi ft. That's it. Okay, so the p sub 0, p0 is not a like term with rho g h. So again, weird Greek letter that looks like p that's actually rho. So we're going to move that not like term over to the other side. Okay, p, no, that looks like a rho. Crap. Oh, look, I have an undo button. Yes. Okay, so p minus p0, that's almost like a delta p. Anyways, final minus, yeah, initial. Yeah, it is. It's a delta p. Look at that. Equals rho g h. And now we need to solve for g, so we're going to divide both sides by rho h. Okay, so p minus p. Can I write my characters the same way? P minus p0 over rho h equals g. Lovely. Okay, cool. Solving for the h here. Yes, easy. That's rho g divided by rho g. H equals p gauge divided by rho g. Okay. Oh yes, another easy one. Just divide both sides by v2. And that'll give us a2, and we are ready to roll on with that. A2 equals a1, v1 divided by v2, and that's it. Sorry about that stray mark. And no, I'm not going to fix it because I can't really get to the eraser symbol right now, so we're just going to go with that. Okay. Yep, this one, divide by rho g, we're golden. Okay, so V equals if B, these are all fluids equations, we'll get to those eventually, maybe. How many days have we been out of school? You know, see what happens. Why? Okay. Yeah, so let's subtract the not so like terms from both sides, which will be minus P2. I gotta make that P look more like a P than a rho. Okay, P2 minus rho G Y. This is Bernoulli's equation 2. Okay, so we're going to move those over to the other side. Oh dear goodness, I don't want to write all those, but I'm going to P1 plus rho G Y1 plus 1/2 rho V1 squared. You know, that's almost like kinetic energy, and that's almost like gravitational energy. That's amazing. Anyways, because they're quite related, minus P2. This is literally conservation of energy. Bernoulli's equation is conservation of energy relating to fluids. Okay, minus rho G Y2 equals 1/2 rho V2 squared. Yeah. Okay, so now we need to divide both sides by 1/2 row. Yep, we're doing it. Okay, once we do that, the 1/2 row will cancel out over here. We got something squared. We're going to take the square root of this thing, and I guess I could move the 2 up to the top. I'm going to take the approach that I suggested in the other video, which is don't do more algebra than you really absolutely have to. You don't want to start, yeah, I don't want to write it again either. So there you go. So I'm going to stop there, and that's good. Okay, cool. Thanks for watching. If you made it all the way to the end, can't find my mouse. There it is. Okay, bye.